today's video, we're going to be talking more about forces. Specifically, we're going to talk about what a net force is, how to calculate it, and the difference between balanced and unbalanced forces. So in order to understand the motion of objects, we have to know how to find net force and what a balanced force and an unbalanced force is. So before we talk about those things, let's take a moment and look at these two examples of objects and their motion. So if you think about a rock sitting on the ground, it certainly doesn't take long to think about what kind of motion that rock is going to experience as it sits there. Well, none. It will just sit there. However, if we think about a golf ball that's sitting on the golf tee, when you swing your club back and smack the ball as hard as you can, the ball is going to move, fly through the air. Then eventually the ball is also going to inevitably fall back down, land on the ground, and stop moving. So why is it that these two objects are experiencing such different types of motion? The answer behind this lies in the idea of a balanced versus unbalanced force. In order to determine if a force is balanced or unbalanced, we must first determine the net force acting on the object. So let's talk about what that means. So the word net, in terms of mathematics, means sum, or all of the things added together. So when we talk about the net force acting on an object, we mean the sum, or the addition, of all of the forces acting on an object. In order to determine the net force on an object, you want to look in each direction and add up, or sum, the forces acting in each direction. In order to do that, you have to set up some sort of coordinate system and determine which direction is positive and which direction is negative. Because when we sum forces that act in opposite directions, like up and down and right and left, must have opposite signs because they are working in opposite directions. Let's look at an example of finding net force. So here we can see, just make up an object, maybe this is the golf ball, two forces that are acting on this object. First, we see here a 5 Newton force acting to the left. We also see here a 10 Newton force acting to the right. In order to determine the net force, I'm going to need to sum or add together all of the forces, which in this case is just those two. Now, I can see that these forces are acting in opposite directions. One is moving directly to the left, the other in the opposite direction, directly to the right. For this reason, they must have opposite signs. To make a quick rule that is easy to follow, I would say to make the larger of the two signs positive. However, if you have a coordinate system set up in terms of a direction that an object is moving, you also can make your determination of sign based on that. In this case, we will say that the 10 newtons is our positive and the 5 newtons, or to the left, is our negative. For that reason, my net force will be equal to 10 newtons minus 5 newtons, or plus negative 5 newtons if you were to break it down, which gives us 5 newtons. So we could say that the net force acting on whatever object this is 5 newtons positive, or 5 newtons in the rightward direction. Now that we know what net force is, we can talk about what a balanced and an unbalanced force is. So balanced forces, you can think about what it means to be balanced, are forces where the net force equals to 0. Let's look at an example. Here we can see that on this object we have a 5 Newton force acting directly to the left and a 5 Newton force acting directly to the right. If I were to sum those to find the net force, I would have 5 newtons minus 5 newtons, or 5 newtons plus negative 5 newtons, which equals 0. That means that the forces acting on this object are 0. You can also see visually it looks balanced. We have 5 on one side and 5 on the other. An unbalanced force, on the other hand, is when the forces add up to, or the net force in a direction is not equal to 0. Here we have another example where we can see a 10 Newton force acting in the right direction and a 7 Newton force acting in the leftward direction. This means that these forces are unbalanced because the net force here would be 10 newtons minus 7 newtons, which gives us 3 newtons. It doesn't matter what that value is, as long as it's not 0, we can see that these forces are unbalanced. So now let's look at some examples of finding or calculating the net force acting on an object. So in this first example at the top, you can see here that we have 2 forces acting on this object. So in order to determine the net force, the first thing that we want to do is to set up some sort of coordinate system to determine the direction of my forces. So one easy way to do this is to just set up a classic coordinate system like you would in math class with your positive x direction pointing to the right and your positive y direction pointing upwards. In that case, that would make one of these forces, the one pointing to the right, be positive 10 newtons, and the force pointing to the left, a negative 10 newtons. So if I were to sum up my forces, I would simply add together those forces in the x direction, which would give me 10 newtons for that rightward facing force, plus negative 10 newtons for that leftward facing force. 10 plus negative 10 we know is equal to 0. So we can say that the sum of the forces, or the net force on this object, is 0 newtons. We know that that means that this sum of forces, or net force on the object, is what we would call balanced, because the net force is equal to 0. In our next example here, we'll see another object that has 2 forces acting upon it, except in this case, both forces are pointing in the same direction. So using the same xy coordinate system as a rule here, we can go ahead and sum our forces as 10 newtons plus 10 newtons, because they are both pointing in that right direction, or positive. 10 plus 10 equals 20. So my net force, or the sum of my forces on this object, is 20 newtons. Now, because this force is not 0, we do want to mention which direction this is pointing in. So since it is positive, we know that this is to the right, or we could say in the positive x direction, or just to the right. We also know that since the sum of the forces is not 0, this is what we call unbalanced. So the forces acting on this particular object are unbalanced, and they're unbalanced in the rightward direction. Here we have another example, 2 forces acting on this object, one in the positive x direction, one in the negative x. So we'll go ahead and sum our forces as 8 newtons, which is my positive or rightward facing force, plus negative 10 newtons, because that force is acting in the negative x direction. Positive 8 plus negative 10, we know, gives us negative 2. Now, force is 2 newtons, but there's no such thing as a negative 2 newton force. That negative is telling us the direction of the force. So if we were to actually describe this force, we would want to say that this is a 2 newton magnitude force pointing in the left, or to the left. We could also say in the negative x direction, which again we know is towards the left. We'll look at another similar example here. Very much the same as what we've been doing, except now we're looking in the vertical, or the y direction. Now we can see that this upward facing force is a tension. So just to give you some perspective here, this might be a Christmas tree hanging, or a light hanging from a string. Since it's a tension, we know it's something hanging from a string or something similar. So we can set up a very similar coordinate system as we did before, with the positive x direction facing to the right and the positive y direction facing up, just to give us a coordinate system to work with. So that tells me that I have a 1200 newton force in the positive direction and an 800 newton force in the negative direction. So if I sum my forces in the y direction, I will have 1200 newtons plus that negative 800 newtons, because that is facing in the negative y direction. 1200 plus negative 800 gives me positive 400. Remember that we want to say a direction, so since it's positive, we know that it is facing upward, or we could also say in the positive y direction. Here we'll look at one final example, slightly more complicated, but using all of the same concepts that we've practiced in the previous examples. Here we can see that we have 3 forces acting, and that 2 of them are in the vertical direction and 1 is in the horizontal direction. So in this case, we will have to sum the forces in both the x direction and the y direction. Since there's only 1 force acting in the x direction, it's pretty basic. There's nothing to sum. The sum of the forces in the x direction is simply that 20 Newton force. Now, we do want to keep in mind that that force is pointing in the leftward direction. So we, again, would not call it negative 20 newtons. We would just call it 20 newtons to the left, or we could say in the negative x direction. Now for my y forces, we'll use the same coordinate system, sum the directions in the y, sum the forces in the y direction. We have a positive 50 newtons, that upward facing force. Then we have a negative 50 Newton force, or downward, so we'll say plus negative 50 newtons. 50 plus negative 50 gives me a sum of 0. So we can say the net force on this object in the y direction is 0. We know that that means that in the y direction, the forces are balanced. However, in the x direction, we know that we have that net force of 20 newtons. So we would say in the x direction, the forces are unbalanced.